Well, here we are, part 22 of 24, and this is the one we've been building toward the whole series. Today, we're going to stand up a real VPS end-to-end, provisioning a fresh server, hardening it, deploying an actual web app, automating backups, and wiring up monitoring. By the time we're done, you'll have a real machine on the public internet doing real work. So let's get concrete about what real work actually means here. We're building 4 things that work together. A public web server running Nginx with a proper Let's Encrypt certificate on a real domain. A hardened box with keys-only SSH on a non-default port, UFW locked down, and fail-to-ban watching for bad actors. Nightly rsync backups to offsite storage that satisfy the 3-2-1 rule. And basic monitoring with health checks, journal logs, and alerts when disk or load get unhappy. Each of these maps back to lessons from earlier in the series. Today we just bring them all together on one machine. To get there in a single weekend, we'll move through 5 phases in order. And the order really does matter, because each one assumes the previous is solid. We start by provisioning the VPS and getting it fully updated, then harden it before anything sensitive ever touches the box. Once it's safe, we deploy Nginx and your site behind HTTPS, set up backups with a real restore drill, and finally add the monitoring layer on top. Notice the right column. Every phase points back to specific earlier parts of the series, so nothing here is brand new. We're just assembling it. So phase 1. Pick any provider you like. Hetzner, DigitalOcean, Linode, they're all fine. Spin up the smallest Ubuntu 24.04 instance they offer. Once it's alive, you SSH in with that temporary root password from the welcome email, and the very first thing you do, before installing a single package, is run apt update and upgrade. Then set a real hostname so you're not staring at some random string in your prompt for the next 2 years, and fix the time zone so your logs make sense when you're reading them at midnight. That's the whole provisioning step. Now, the moment that machine is online, bots are already knocking. So phase 2 cannot wait. Create yourself a normal user with sudo rights, push your SSH key up from your laptop with SSH copy ID, then edit SSGE config to kill root login and password auth entirely, just like we did back in part 13. After that, open the firewall for SSH, HTTP, and HTTPS. In that order, allow first, enable second, or you'll lock yourself out. And finish with fail-to-ban to swat away the brute force attempts that will absolutely come. With the box locked down, we can finally serve something. apt installs Nginx, systemctl enables and starts it in one shot, and a quick status check should show active and running in green. From there, copy your site files into var.html. That's the default web root Nginx already knows about. And curl localhost to confirm bytes are coming back. Punch the server's IP into your browser, and there it is. Your machine on the public internet doing real work. Now serving plain HTTP in 2026 just isn't acceptable, and thankfully, Let's Encrypt makes the fix almost trivial. Point your domain's A record at the VPS, install certbot with the Nginx plugin, then run certbot once. It'll talk to you, ask which domain, and rewrite your Nginx config to redirect HTTP straight to HTTPS. The renewal happens automatically through a system timer, and you can confirm it's armed with list timers piped through grep. 2 commands, real TLS, done. With TLS in place, the next step is making your app behave like a real service instead of something you babysit in a terminal. Drop a small unit file under etc. system. Give it a unit, service, and install section. User, working directory, exec start, and crucially restart equals always, so a crash just means a quick respawn. Then it's the familiar 3-step dance. Daemon reload to pick up the file. Enable, now to start it and arm it for every boot, and journalctl u myappf to watch the logs stream live. With the app running on its own, you want to make sure you can survive losing the whole VPS, and that means backups you don't have to remember. This little script is the template from part 18. Set EO pipe fail so it fails loudly, a tiny log function for timestamps, and rsync pushing, etc., home, and opt app to an offsite backup host under a folder named after this machine. Then cron runs it nightly at 3 in the morning, wrapped in flock so 2 runs can never overlap. Backups in place, you need eyes on the box, and resist the urge to install a full Prometheus stack on day 1. 4 cheap checks cover most disasters. A cron job running systemctl is active and emailing you if the app dies. A DF check that screams when you drop below 15% free, and a find on the backup log that catches a stale touch file older than 26 hours. Because no backup means no production. Then once a week, 10 quiet minutes scanning auth.log and journals.tl errors. That's it. You can always add fancier tooling later, but this alone will catch the outages that actually hurt. So how do you know you're actually done? Run through these 8 checks, and don't lie to yourself on any of them. The site loads over HTTPS clean, root SSH is refused, your user logs in with a key only, and the firewall shows just 22, 80, and 443. The app survives a kill. Last night's backup is in the log. You've actually restored a file on purpose, not just hoped you could. And every mount has headroom. Tick all 8, and you've got a real production box. And if you breeze through all 8 and still have weekend left, here are 4 directions to push further, roughly in order of difficulty. Containerize the app with a Docker file. Bind mounting config and using a named volume for data. That's Part 19 territory. Put Nginx in front as a reverse proxy, with your app bound to localhost on 8080 and Nginx handling 443. Then automate the whole thing with a single setup.sh that takes a fresh VPS to fully configured. And finally, expose a status endpoint and let something like Uptime Robot watch it from the outside. Before you dive in, let me flag 3 traps that catch almost everyone. First, an untested backup isn't a backup. It's a wish. Actually pull a file back from your offsite copy and verify it. Otherwise, you'll find out it's broken on the worst possible day. Second, don't tell yourself you'll harden the server after the demo. Bots are scanning your ports within minutes of boot, so the phase order in this project genuinely matters. And third, never commit secrets to Git. Once a password lands in history, it's compromised forever. Put .env in .gitignore on day 1 and keep keys on the server. Now step back for a moment and look at what you've actually assembled. SSH with keys from Part 12, fail2ban and UFW from Part 13, your systemed unit from Part 9, cron with flock from Part 16, Nginx and HTTPS from Part 11, rsync backups from the storage parts, and journals.tl monitoring tying it all together. Every box on this slide is a skill you've already practiced. You're just running them all at once now on one real machine. So if nothing else sticks from this project, hold on to these 5 things. The phase order matters. Provision, harden, deploy, backup, watch. Because bots really do start scanning within minutes of first boot, and skipping ahead is how machines get compromised. Backups only count if you've actually restored from them, and a tiny monitoring setup checking 3 things will catch almost everything that goes wrong. And number 5, take it seriously. You built a real server. That's portfolio material, not a tutorial exercise. And that brings us to Part 23, where we'll zoom out from this single server and talk about where you go from here. The career paths this kind of work opens up, the certifications worth chasing, and the deeper topics waiting once the fundamentals feel natural. You're 22 of 24 now. The hard part is behind you. I'll see you in the next one.